Okay, we're now looking at our third type of mathematical induction type question, inequalities. First example, example 1. First example is to prove that, and you can see it's an inequality type because you've got a greater than sign here. So prove that 3 to the power of n is greater than 1 plus 2 times n for all positive integers n greater than or equal to 2. Again, the steps are the same. So, step 1. Prove true for n is 1. I'll just write for n equals 1. What have we got? 3 to the power of 1. Is it greater than 1 plus 2? Oh, sorry, girls. It's not for n is 1. What do we start with? N is 2. You notice that it actually doesn't work for n is 1? For n is 1, you get 3 is greater than 3. That's not true. So for n is 2, just be careful here. For all positive integers, n greater than or equal to 2, we've got 3 squared is greater than 1 plus 2 squared. So 9 is greater than 1 plus 4, which is 5. That's true for n equals 2. So just be careful, girls, that you're starting on the correct integer. So that's step 1. Step 2, assume true for n equals k. That is, we are assuming that 3 to the power of k is greater than 1 plus 2k.
Do we have to rearrange?
Not sure yet. We'll see what happens. Girls, that's a 3 to the power of k is greater than 1 plus 2 times k. Step 3, we need to prove true for n equals k plus 1. That is, we are trying to prove that 3, what? To the k plus 1 is greater than 1 plus 2 times k plus 1. That's what we're trying to prove. We're trying to prove that 3 to the power of k plus 1 is greater than 1 plus 2 to the k plus 1, which really is, what's that, 1 plus 2k plus 2, which is what? I will leave it like that. Which is what? 2k plus 3. That is, we're trying to prove that 3k plus 1, that is, that 3 to the power of k plus 1 is greater than 2k plus 3. Yeah, that's how we'll start in a minute. So this is what we're trying to prove, this row here. Okay? So notice I've simplified it, otherwise your answer has to look like that. And I'd repeat it again. Alright? So let's start with our left-hand side. We've got 3 to the power of k plus 1. What does that equal? Yeah. 3 to the power of k plus 1 is equal to 3 to the k times 3. Now, look at the assumption. They're saying that 3 to the power of k is greater than 1 plus 2 to the k. No, 1 plus 2 times k. So you replace the 3 to the power of k with a greater than 1 plus 2k. So even though that equals that, I say, well, that therefore is greater than, I'm going to put my normal 3, 1 plus 2 to the k, reason, since 3 to the power of k is greater than 1 plus 2k. All right, girls, I know you're finding this a bit tricky. When it's equal, you put an equal. Now, what I'm doing is replacing, I know that 3 to, see, I can put that greater than here, and you'd feel better. But I just put it on the next line. That is greater than, look, 3 equals 3, doesn't it? The 3's are the same, but 3 to the k is greater than 1 plus 2 times k up here. So I've got 3 to the power of k plus 1 equals 3 to the k times 3, which happens to be greater than, there's that 3 times 1 plus 2 to the k. It's because this 3 to the k is greater than 1 plus 2 to the k. Now, that equals, I'm writing equals now because I'm just expanding in this. That equals 3 plus what? Do you know why I'm putting equals on the next row? Because what I'm writing on this row equals what's above it. Equals 3 plus 6k. Wait a sec. Because 3 times 2k. Now, I'm trying to show that 3 to the k plus 1 is greater than 2k plus 3. Okay? So, therefore, isn't that actually equal to 3? No. No. That row equals this row. But look, that is still greater than... If I'm just changing, that is greater than this, but this row equals that. Would you say that this is... If I put a greater than here, it means this is greater than that, but it's not. Because I'm using the assumption, because 3 to the power of k is greater than 1 plus 2k, you can't put equals on this row. Yeah, but just wait. Yes, I know, but the next row equals the row above. Look, what you do, don't worry about this anymore. From there, that is greater than the row above it. This equals the row above it. Doesn't 3 plus... 3, yes, but I've still got the greater than here, so it's okay. So this is still greater than this because of this greater than. If you put greater than here, it means that you're saying that what I've written here is greater than that, and it's not. It equals that.
Yeah, but doesn't the second row equal the first row?
No, the second row is greater than the first row because the substitution is not 3 to the k equals 1 plus 2k. It's 3 to the k is greater than. Girls, whenever you're just expanding and not changing the value, you put equals. Do you see what I'm doing here? Don't worry, this is still greater than this because of this greater than sign here. But I've just said that that equals this. Now that there, I can do this a few ways. I can say I'm trying to prove that 3 to the k plus 1 is greater than 2k plus 3. I've got the 3, but I've got 6k. Girls, isn't 6k bigger than 2k? So therefore, 6k plus 3 is definitely greater than 2k plus 3, isn't it? So I can either say that, well, this is equal to 3 plus 2k plus 6 plus 4k. Are you okay with that? This line equals that. You okay with that? Which obviously, that line, isn't that line greater than 3 plus 2k? That's what you're trying to prove. 3 to the k plus 1 is greater than. So therefore, so what I'm doing, you don't have to write it like this, but I like writing it like that. Because 3 plus 6k is 3 plus 2k plus 4k. Well, whatever that is, that's greater than 3 plus 2k. So therefore, 3 to the k plus 1 is greater than 2k plus 3. You know, which is... Yeah. So, therefore, if the result... We're going to do a few of these, girls. If the result is true for... No, since. No, if. If result is true for n equals k, then it is also true. Because remember, your first conclusion is based on what you've just done. If the result's true for n equals k, then it's also true for n equals k plus 1. Then since result is true for n equals which one? 1 or 2? 2, then it is also true for n equals 2 plus 1, which is 3, 3 plus 1, which equals 4, and so on, for all n greater than or equal to 2. So if the result is true, see, we're making the conclusion about what we've just done. So we say if it's true for n equals k, then it's also true for n equals k plus 1. Since it's true for n is 2, then it's therefore true for 2 plus 1, which is 3, 3 plus 1, which is 4, and so on, for all n greater than or equal to 2. Now, in some books you won't see this step, the 3 plus 2k plus 6k, but I like that because obviously 3 plus 2k plus 4k, sorry, is greater than 3 plus 2k, isn't it? Because if k is 1, like that, 3 plus 2k plus 4k is definitely greater than 3 plus 2k because it's got an extra 4k on it. All right? All right, we'll do some more. Ready? Yay or nay? Underlined it. 5 to the power of 1 is greater than or equal to 1 plus 4 times 1. Is that true?
Yeah.
5 is greater than or equal to 5. Yes, it's true. 4. N equals 1. Assume true for n is k. That is, we're going to assume that 5 to the k is greater than or equal to 1 plus 4 times k. Now, we've got to get our greater thans and our equals correct. Our greater than on the next row is when what you're writing is definitely greater than what you've just written, and your equals is when your writing on the next row is equal to what you had just written. Does that make, okay? So prove true for n equals k plus 1. That is, we're going to prove that 5 to the power of k plus 1 is greater than or equal to 1 plus 4 times k plus 1. In other words, see, do you know why I'm rewriting this instead of putting, oh, I could put equals, but I'd rather write it the way you're going to do it. What have you got? 1 plus 4k plus 4, so it's 4k plus 5. That's what you're trying to prove. That 5 to the power of k plus 1 is greater than or equal to 4k plus 5. And you can start with your left-hand side, which is 5 to the k plus 1. And you get moving now. I'm going to stop now. Yeah, good. 5, isn't it 1? Oh, yeah, 5, yes, good, good, good. Yes. Great, great. Okay, girls, now, so we've got 5 to the k plus 1 equals 5 to the k times 5 to the 1. Now, we know that 5 to the k is greater than 1 plus 4k. So therefore, the 5 is this. 5 to the k times 5 to the 1. 5 to the k plus 1 equals 5 to the k times 5 to the 1. You okay with that? Now, we know that the 5 to the k is greater than 1 plus 4k. So I'd like to put this 5 in front, because when you've got a number outside brackets, it's nice to have the number in front of the bracket as opposed to behind it. So that 5 is greater than or equal to 1 plus 4k, which happens to equal 1 plus 20k. You're just trying to show that it's greater than 4k plus 5. Now that happens to equal 5 plus 4k plus 16k. Now that's obviously greater than or equal to 5 plus 4k. Can you put here, please, using assumption from step 2? You should. Just put using the assumption is even good. So,
What did you do with 16?
well, if I've got 5 plus 4k plus 16k and k is positive, isn't that line there bigger than this line? And that's why I put greater than or equal to now. Look, the only time it would ever be equal to it was if k is 0. And actually, our values only start from k is 1, but don't worry about it. You still put greater than or equal to, because that's the result you're trying to prove. It would only be equal if k was 0. All right? So, yeah. Actually, the original result won't be equal when k is 0 anyway. But look, I wouldn't go changing it and putting a greater than. Yep. So therefore, 5 to the k plus 1 is greater than or equal to 4k plus 5. Right. If true, n equals k, then it is also true, or just true, for n equals k plus 1. Then since it is true for n equals 1, then it is true for n is 1 plus 1, which is 2, 2 plus 1, which is 3, and so on, for all n greater than or equal to 1. All right, let's find some others. I've got some other harder ones, but look, 5 to the power of 3 minus 3 is greater than 4 to the 3 plus 20. 5 to the power of 3, is that 125?
Yes.
Minus 3 is 122. Is greater than 4 cubed is 64 plus 20, 84. Therefore, true for n is 3. Assume true for n equals k, that is, you can assume that 5 to the k minus 3 is greater than 4 to the k plus 20. I'm thinking, let's do 5 to the k is greater than 4 to the k plus 23. I think we need to rearrange that one. I can't see us doing a substitution for 5 to the k minus 3. Okay? So I would take that to the other side. Assume that 5 to the k minus 3 is greater than 4 to the k plus 20. I can't see us, like I said, doing a substitution for 5 to the k minus 3. Let's take that 3 over to the other side. We're going to do the substitution 5 to the k is greater than 4 to the k plus 23. Step 3, prove true for n equals k plus 1. That is, you're trying to prove that 5 to the k plus 1 minus 3 is greater than 4 to the k plus 1 plus 20. No, I think it's okay. Just leave it. Oh, you're saying to make it 23. Rearranging here that we want. Yeah, wait. Let's start with the left-hand side. Left-hand side is equal to, you're only allowed to start with the left-hand side. Is that, which equals
5k times 5.
power of k plus 1 minus 3 equals. That's all you're allowed to start with. You're trying to show that it's, actually, girls, that it's greater than 4 to the k plus 1 plus 20. That's what we've got to show. Start with your left-hand side. What can you do? 5 to the k times 5 minus 3. What do we replace now? And what don't I do? I put a greater than because I'm doing my replacement for 5 to the k. So now I put that line above is greater than, let's put the 5 first, 5 times what?
4k
plus 23 minus 3. Now that happens to be equal to 5. No, 5, because it's not, it's 4 to the power of k. Let's say k was 2. That means 5 times 4 squared, which is 5 times 16, which is 80. If you do 20 to the power of 2, that's 400. Okay, so girls, please don't, you only multiply whole numbers together. So that happens to equal 5 times 4 to the k plus, what's 115 minus 3, which happens to equal, notice I'm just putting equal when I'm just manipulating, expanding. That equals 5 times 4 to the k plus 112. Now you're trying to show that this is greater than 4 to the power of k plus 1 plus 20. Now, girls, this is what I'm going to do now. This one's slightly different. If I want to get 4 to the k plus 1, how do I get that? 4 to the k times what? Times 4 to the 1. So isn't 5 times 4 to the k greater than 4 times 4 to the k? Right? And isn't, now I'm going to do something different. All right, if you want the way that the book does it, this is what, the way that we've been doing it, this is what you would do. You'd come across here and you'd say, well, doesn't that equal, just leave this at the moment, doesn't that equal 4 times 4 to the k plus 1 lot of 4 to the k plus 20, you know how we're trying to show that it's greater than, plus 20 plus 92. That's what we've been doing so far.
Wait, where did the 4 times 4 to the k?
Well, if it's 5 lots of 4 to the k, I'm trying to get 4 to the k plus 1, which is 4 to the k times 4 to the 1. That 5 lots of 4 to the k, look, I think we're going to go with this other method from now on, all right? 5 times 4 to the power of k is the same as 4 times 4 to the k plus 1 times 4 to the k. It's like me saying 5x is 4x plus 1x. 5 lots of that equals 4 lots of that plus 1 lot of that. Now, I know you're finding this difficult, so I think this is the last time we're going to do that. See how, well, isn't that what I've written there? Greater than 4 times 4 to the k plus 20.
Yeah.
Now, you can do it that way if you want, by breaking it up to get what you've got up here plus adding on the extra bits. That's one way of doing it. Or the way that they do it in the book, 5 times 4 to the k, it's obviously greater than 4 times 4 to the k, isn't it? And 112 is greater than 20. Now, what you do, if you're going to do it that way, you need to write next to it, since 5 times 4 to the k is greater than 4 times 4 to the k, and 112 is greater than 20. Okay? So, this row, that is greater than this because you look at the two things. 5 times 4 to the k is greater than 4 times 4 to the k, and 112 is greater than 20. So you can either do it this way where you're breaking it up and then writing that, or you can write that on the next row and in brackets next to it you'll write since. See, to say that this is greater than that, you've got to show me that 5 times 4 to the k is greater than 4 times 4 to the k, and it is. 5 times, let's say k is 3. 5 times 4 cubed is greater than 4 times 4 cubed. And we know that the 112 is greater than 20. You'd have to be able to show that both those things is greater than both the things you're going to write there. So, who likes this straightaway inequality? That's how the textbook does it. The other way, but just be very careful here, I'd be thinking of my 4 to the power of k as like x, just an x, 5 lots of x, is the same as 4 lots of x plus 1 lot of x. Get the idea? 5 lots of that. 5 times something, you know, in primary school, 5 times 2 means 5 lots of 2. 5 lots of 4 to the k is 4 lots of 4 to the k and another 1 lot of 4 to the k. And the 112 is 20 plus 92. Obviously, that row is greater than this because you've got the extra 1 plus 4 to the k and you've got the extra 92 there. Okay? And then your conclusion. Okay? Therefore, if it's true, etc., for n equals k, then it is also true for n equals k plus 1. Now we need to do more of this type. Since it is true for n equals 3, then it is also true for n equals 3 plus 1, which is 4, 4 plus 1, which is 5, and so on, for all n greater than or equal to 3. Now we need to do some more of this type. So the other type, see, when you've got the two powers on both sides, you've got to say, well, 5 lots of this power is bigger than 4 lots of that power and stuff like that. We need to do another one of these. I might see if I can find, actually I'll be giving you past HSC ones to do anyway, so we'll just do another one in the book. We will do question, I'm just seeing if I've got some. I've got other types to do harder ones. I'm going to do them tomorrow. 12 to the power of n is greater than 5 to the power of n plus 7 to the power of n for all integral values of n greater than or equal to 2. I will stress here, please make sure you use the assumption. Because I've got here in my working, yes, I've gone merrily about my way doing it, but it didn't use the assumption, so I crossed it all out and made sure I went back and used the assumption. Induction only works, is only valid if you're using the assumption from step 2. Right, if you start off on a path and you think it's wrong, just stop it, go off on another path, but don't cross the original path off until you finish the other one. Because once you put a cross through it, they're not going to read it. Okay? So there's been changes to the rules. So do not leave anything blank for any question. If you think it's wrong, just leave it there for a minute, do your next bit. Yes, if you're happy with that, cross the other one out. And just put a line through it. Don't scribble it so that they can't see what was ever there in case they will read it. All right? For n equals 2, 12 squared is greater than 5 squared plus 7 squared. What's that? 144 is greater than 25 and 49. What's that? True.
Right. Oh, wait, yes.
True for n is 2. Step 2. Assume true for n equals k plus 1. That is, you are assuming that 12 to the k plus 1 is greater than 5 to the k plus 1 plus 7 to the power of k plus 1. Oh, sorry. What's wrong with me? K's. Sorry. That's that one. Then step 3, prove true. So it's just 12 to the k is greater than 5 to the k plus 7 to the k. Sorry, jumping ahead. Prove true for n equals k plus 1. That is, you're trying to prove that 12 to the power of k plus 1 is greater than 5 to the power of k plus 1 plus 7 to the power of k plus 1. I would leave it like that. Power of k plus 1 is 12 to the k times 12. Now break up the normal 12, not the 12 to the k. Normal 12 is 5 plus 7, yeah, times 12 to the power of k. Are we okay with that? 12 to the power of k plus 1 is 12 to the power of k times 12. Notice we're trying to get a 5 and a 7. I hope I'm doing this right. Okay, so that equals 5 to the... Oh. 5 times 12 to the power of k plus 7 times 12 to the power of k. Actually, you know what? Couldn't I have just... you know what? Why don't we... I don't know. It will work, but I'm just going to do it another way that you'd more than likely use, okay? What would you do now? What would be your next step? Wouldn't you do the assumption? Yeah, greater than 12 times 5 to the k plus 7 to the power of k. Actually, there's nothing wrong with this. Now that happens to equal 12 times 5 to the k. I'm likely going to do this method rather than the other. So let's just stick with this. So it's 12 to the k times 12, which is greater than, we're replacing 12 to the power of k with greater than 5 to the power of k plus 7 to the power of k. Now that line there, I'm just expanding, happens to equal 12 times 5 to the k plus 12 times 7 to the k. But look at what we're trying to do. We're trying to get 5 to the k plus 1. Isn't that 5 to the k times 5 to the 1? Now, isn't this row greater than 5 times 5 to the k plus, what do you think? I want to get 7 to the k plus 1. How am I going to get that? Isn't that 7 to the k times 7 to the 1? So isn't 12 times 7 to the k greater than 7 times 7 to the k? And isn't 12 times 5 to the k greater than 5 times 5 to the k? All right, so there, look, we were going to do exactly the same thing before anyway. So we're writing that, and then we'll go here, since 12 times 5 to the k is greater than 5 times 5 to the k, and 12 times 7 to the power of k is greater than 7 times 7 to the k. Do you understand why I'm choosing 5? Because, isn't that 5 to the power of 1? Bases are the same. What does that equal, 5 times 5 to the k? 5 to the k plus 1, because that's 5 to the 1. So I'm actually going to write it, expand it so you can see. That's equal to 5 to the 1 times 5 to the k plus 7 to the 1 times 7 to the k, which equals 5 to the k plus 1 plus 7 to the k plus 1. So now I can say, therefore, because I've got two greater thans, this is greater than that. It doesn't equal that. It's greater than that because there are a couple of greater thans down that left-hand side. So therefore, 12 to the power of k plus 1 is greater than 5 to the power of k plus 1 plus 7 to the power of k plus 1. I really think this is probably the way you're going to go. All right? If you want, I can play around with that other one. But we would have been changing the 12 to the k in that other case. All right? So I think this is easier. All right? All good. In step 2. All right, why did we put that that's greater than that there? We've used our assumption. Now we're just manipulating. Now we're saying that that row above there is greater than this row here. Manipulation, manipulation, final conclusion. All right, so therefore, if true, remember your first part of your conclusion deals with steps 2 and 3. If it's true for n equals k, then it is also true for n equals k plus 1. Since it is true for n equals 2, then it is true, also true for n equals 2 plus 1, which is 3, 3 plus 1, which equals 4, and so on for all n greater than or equal to 2.